Okay, that's why we say it's unequivocal. And you'll often see people in the blogosphere or other places say, oh, well, there's something wrong with this or that. They're nitpicking. Climate scientists are willing to argue about any one of these things, but it's just totally overwhelming when you include all of these things together. They're all changing in a consistent way. And no one has challenged that. All right, so let's turn to the Colorado, because I want to bring this home to us. What does it really matter? We already got some stuff in the news. We know the Colorado Basin is hurting. Trees are dying. The water level is lower than it's been in a long time. What's going on right in our backyard? Here is the Colorado River Basin, stretches up to Wyoming. All these red dots are the big cities that it serves. A lot of people in the West care about this river. Sorry, I put the biggest dot in Tucson. You can understand after the basketball game. Okay. I can tell you got some U of A fans. It has 7 states. It has a lot of people. It has some of the largest cities in the nation. Increasing political clout. A substantial portion of the nation's agricultural production, when we include that this water is fueling a lot of what's going on in the most fertile parts of California as well as parts of our state. Large concentration of native nations. There are a whole bunch of reasons why this basin is really critical, not just because it's our drinking water. Okay? It is, before the recession and likely after the recession, the part of the country that's growing the fastest. Nevada and Arizona vie for the fastest growing part of the country. All right? But the state that's growing the most in terms of number of people is California. Like, you put us all together, and this is the fastest growing. People are moving here. And so it's very ironic to me that we're growing the fastest in terms of people, just as we're starting to really see the signs of climate change. Water is already over-allocated. I'm going to make the case today that Colorado is hurting in part because of climate change. But it's wrong to assert that Lake Mead is at its lowest point since the 30s when it was filling, solely because of climate change. It's also because the use of that water, we now have a consumption that is greater than supply. And one of the sad things is that the water in that river was divided up in the 1920s when we had just a teeny record of how much water there was in an average year. And we overestimated the amount of water that should be flowing in that river on an average year. So we said, let's divide that river up 16 million acre feet. These are these basic units we use for the water on the river. 16.5 million acre feet of water flows an average year. And we divided it all up among the basin states and Mexico. And then we discovered, as we started developing more clearing records of past flow, I'll show you one of these later, that the average flow is only like 14.5 million acre feet. So the problem we're in now is because of climate, this lake has taken, this river has taken a real beating. The reservoirs are low, and because we're using water, all the water that normally flows in that river, it's getting much harder to fill it up. We might never see these reservoirs full ever again because of that, and because climate change is going to continue to get drier, as you'll see in a minute. Let's look at that now. This last summer, Brad Udall and I published a paper in Science Magazine just summarizing. It's very short, it's written for a broad audience. You can read it if you're more interested in this. It has the scientific citations behind this work. And we talked about the climate change in the basin. And we pointed out, unlike many parts of the world where climate change is still kind of hard to see and feel in day-to-day lives, in the Colorado Basin, it's abundantly clear what's happening. What is happening? What does it mean for the future? Well, the basin is warming. We've warmed about, we've warmed more than the global average. And we should continue to warm. In fact, because all the models suggest we should continue to warm, we've already seen as much warming than the models suggest should happen. You could say it's almost a sure bet that this region's going to keep warming. Not necessarily every given year warmer than the past year, but over 10, 20 years from now, we'll see a lot of warming. All right, you can just see here the average temperatures of this century, 9 years of this century, minus the average for last century, 100 years, okay? And this is just one way, there are many ways to look at this, but this shows in this century where the warming is going to be concentrated. And you can see it's in the West, particularly in the Colorado River Basin states, right? In the headwaters of Colorado. That's bad news on one hand, right? we're getting the brunt of this warming. It's as bad as anywhere else in the United States, except the highest latitudes in Alaska. That's true, but it's also good because it gives us a lot more confidence in understanding what's going to happen next. Because we have so much confidence in temperature going up, it tells us a few other key things. It gives us confidence in it. Okay? I'll get to those in a second. But first, I want to start talking about where the big uncertainties are. Okay? I've sounded pretty darn sure of myself up here. I'm sure a lot of you are thinking, gosh, he doesn't seem to lead any reason to doubt these things. And it's true. We know climate change is occurring globally. We know humans are causing it with great certainty, 90% sure now, that we're causing the bulk of this warming due to fossil fuel burning, primarily. We know this is causing a lot of other changes that I showed you on that big long list. Those things are all related. The big uncertainty about climate change is what exactly is going to happen in the future. And as I just said a minute ago, I'm going to come back and assert that we're lucky in the sense that we have more confidence in what's going to happen here in the Southwest. Yeah, it's going to be bad here in the Southwest if we're not careful. But at least we can have more confidence in understanding what's happening. And that will give us a real advantage in adapting to it and dealing with it. But where is the big uncertainty? It comes down to how much warming are we going to get in the future, and how much of the magnitude of the warming, and the magnitude of the associated climate changes, which I'll get to, okay, in more detail. And this just shows you the problem we have. What is the biggest source of uncertainty about future climate? It turns out it's the not knowing how much greenhouse gas we're going to put up in the atmosphere into the future. Not knowing how much carbon dioxide we're going to put up there, methane, nitrous oxide, how much fossil fuel we're going to burn, how much fertilizer we're going to create, all these other things that give us these heat-trapping gases in our atmosphere. That's the big uncertainty. We can't predict human behavior. And the story I always like to tell is that even when we were producing this diagram, it was a 4-year process to write this report, a 5-year process. And when we started this, we thought this is a plot here of time versus warming for different greenhouse gas emission scenarios. In other words, differing amounts of greenhouse gas as a function of time. Okay? We thought the fastest we could possibly put greenhouse gases into the atmosphere and warming that would be associated with that would be along this red line. Okay? The other uncertainty is our models, our climate models, which can do a good job of simulating climate change in the last century, in the last 500 years, or the last ages, or other periods of time. But they still have uncertainty around them too, and that's the shading around the red line. You see this red shading. We thought this is as bad as it could get. Well, even during writing this report, we found out that we were starting to get greenhouse gases in the atmosphere even faster than we thought possible to begin with. And that's because China and India came online and their economies went nuts and they started using energy like no one's ever seen before, and they were pretty inefficient in their burning of fossil fuels. And so these greenhouse gases are going up even faster. And so it turns out that instead of just getting a warming by the end of the century about 3 degrees Celsius or 5 or 6 degrees Fahrenheit, we could have warming as much as 6.5 degrees C, according to some models. So there's a good deal of uncertainty here. Will we curb greenhouse gas emissions and get much less warming? Will we not curb them and get a lot more? Will we start, developing oil shale and things like that and really blow this out the top? We don't know. But we do know it's going to warm. And here's the best guess if we have business as usual, keep emitting the amount of greenhouse gas that we're emitting now. We'll have about 10 degrees, and this is averaging multiple models, so this isn't taking the most extreme case. You can get bigger numbers from this, but averaging multiple models, you get warming everywhere. Okay, here's the scale, degrees Fahrenheit. But you get warming of about 10 degrees Fahrenheit, the bullseye, you can see it in the upper base of the Colorado. That's not where we want to see a bullseye, a warming, I should see a bit. It'll be more warming in summer than winter. That's not good for us here in Arizona. This is what we're seeing already. It's just going to continue and get worse and worse. You can see here that the warming is equivalent down here as it is in parts of Alaska. Not that many people in Alaska.